Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on Law of Large Numbers. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint presentation to make this series of videos on probability. Mrs. Borlaug designed this particular PowerPoint presentation to be used after her class had done an in-class activity using beads and the handouts that you see on your screen. I will make this video balancing the fact that some of my viewers have done this activity while most probably have not done the activity. The major concepts should be the same either way. Before we begin, I will need to introduce some terminology that we will use. As I've said in the previous videos, terminology and vocabulary are a big part of a probability and statistics course, and you will need to pay attention to the language and verbiage that your instructor uses. Flashcards are a great way to learn any new vocabulary. Our first word is experiment. An experiment is a process by which we get results, called outcomes, from the population. To help with this terminology, we will start with an example. In this case, a population of 45 cars in a parking lot. An experiment from this example might be to select one car at random. Next, outcome. An outcome is a result from an experiment. From the experiment, our outcome is a particular car, that particular car that we selected at random. For example, the car in parking space number 37. An event is a collection of outcomes. Event R would be a red car. So once we have selected a car, we have that outcome, and then we check to see if it is a red car. We might check to see if it's a Toyota. Is the car I selected a Toyota? Does the car have a sunroof? Event S might be a car with a sunroof. A simple event is an outcome that is a single result. The red Lexus in parking space number 12 would be considered a simple event. Sample space. All possible individual results from an experiment. So our sample space would be the 45 cars in the parking lot. Now it is time to look at another example. Our population consists of 30 students, of whom 9 are wearing sneakers. We're going to run an experiment where we will select one at random and then put it back. Our sample space consists of the 30 students, and our event is wearing sneakers. First, we will discuss the classical approach. The classical approach is based on population information. And to find probabilities using counting, it will only work if the simple events are equally likely. To find probabilities using counting only works for equally likely simple events. So what would the probability of selecting a student wearing sneakers be? I like to draw a picture of my data or represent my data in my own handwriting. So oftentimes I will create a table or a chart, or even just jot down the numbers so that I know what the numbers are. So taking the information from our population, I will say that we have equally likely simple events. Selecting any one of the students is equally likely. We have 9 with sneakers, a total of 30, which will leave 21 without sneakers. And by making this table or chart here, I have taken the information and put it in a way that I understand it. So what is the probability of selecting someone with sneakers? Well, it would be the 9 with sneakers out of the total of 30. 9 out of 30, or 0.30. This is called the true probability. Next, we will discuss the relative frequency approach, or empirical approach. The empirical approach is based on what? It's based on repeating the experiment. So we're going to pretend that we've run the experiment, that I've run the experiment, and we'll say that I ran it 48 times. And each time I ran the experiment, I looked at the student and said, "Are you wearing sneakers?" Got a yes or no response, and put the student back into our population. And I counted the number of times I got a student with a pair of sneakers, and that was 13 times. Then, by using relative frequency, I can find the probability of sneakers from my experiment was 13 out of the 48 times I selected a student. The student was wearing sneakers, which gives me 0.2708, and this is called the relative frequency. This is an estimate of the true probability. If I ran the experiment 48 times again, I could get sneakers a different number of times. The total would still be 48, but I might get more than 13, I might get less than 13 as the number of sneakers that I counted. Here is a sum of the two approaches, or a summary of the two approaches. My estimate, the relative frequency, underestimates the true probability. Will it always be an underestimate? Think about that. Remember, I said I could get more than 13 sneakers or less than 13 sneakers. We'll look at this more in part 2 of this video series. Before we move on and as we conclude part 1, here are some formal definitions of the two approaches. In the classical approach, a population must consist of equally likely simple events. Then the probability of A is the total number of ways A occurs divided by the total number of outcomes. Let me say that again. The probability of A is equal to the number of ways A can occur divided by the total number of outcomes. The relative frequency approach, or empirical approach, the same experiment is repeated, and the probability of A is the number of times A occurs divided by the total number of times the experiment is run. An experiment is such as select one at random, and in the law of large numbers, if the experiment is repeated over and over again, the blank approaches the blank. And using the words true probability and relative frequency, what do you think happens? The relative frequency approaches the true probability. I will end the first video of this set here. If you would like more help with this topic, please watch the second video of this series. And as always, Walter State students are welcome to stop by and see me in MBS 222.